What is retarding the water supply in Texas? Let's find out in this video. Texas Hill Country is running out of water, and in Comal County, they are so low that the Texas Water Company is now denying permits and not having neighborhoods built. Land development is retarding, i.e., damaging or slowing the recharge and health of the Edwards Aquifer through a combination of direct and indirect impacts. Here's a detailed breakdown. Overview: why the Edwards Aquifer is vulnerable. The Edwards Aquifer is a karst limestone aquifer, meaning it consists of porous, fractured limestone that allows for rapid infiltration of rainwater into underground channels. This makes it highly sensitive to surface changes, especially from urbanization and land development. How land development retards the Edwards Aquifer. 1. Impervious cover reduces recharge. Roads, rooftops, and parking lots prevent rainwater from soaking into the ground. This reduces natural infiltration into recharge zones like caves, sinkholes, and fractures. Instead of seeping underground, rainwater becomes surface runoff, flowing into creeks or storm drains and out of the recharge area. In highly developed areas like San Antonio and Austin, over 60% of rainfall can become runoff, compared to just 10 to 20% in undeveloped hill country land. 2. Pollution of recharge. Water runoff from developed land carries oil, heavy metals, pesticides, fertilizers, and septic waste. These pollutants enter karst conduits without natural filtration, threatening the water quality of drinking wells and springs like Comal and San Marcos. Urban runoff reaches the aquifer quickly through fractures, without the sediment and root zones that normally act as filters. 3. Altered drainage patterns. Urban development channels. Water away from natural infiltration zones, gutters, storm drains, and altered creek beds reroute water into engineered outfalls, reducing how much enters the aquifer. Natural stream recharge, e.g., from the Blanco or Helotes Creek, is interrupted by culverts and diversion channels. 4. Quarrying and blasting. Construction often involves blasting limestone, destroying karst features like caves and sinkholes that are critical to recharge. Quarry operations also lower surface permeability and may even puncture the aquifer, causing contamination or permanent drainage rerouting. 5. Increased pumping and water use development leads to more municipal wells drawing water out of the aquifer. When withdrawals exceed recharge, spring flows decline, leading to ecological damage and regulatory limits, like in the Edwards Aquifer Authority's critical period management rules. 6. Loss of vegetation and soil health. Natural vegetation, especially deep-rooted trees and grasses, promotes infiltration and holds soil in place. Urbanization replaces this with mowed turf, gravel, and compacted soil, which do not absorb water well. Soil compaction during construction can reduce infiltration capacity by over 80%. Case study: Northern Bexar and Comal counties. Massive subdivisions north of San Antonio, e.g., Stone Oak, Bulverde, are built over Edwards Recharge Zone. Loss of land to development here directly reduces recharge to San Antonio's primary drinking water source. Despite protective zoning overlays, loopholes and variances often allow construction on sensitive features. What can be done to mitigate the damage? Low Impact Development, LID. Techniques: permeable pavements, rain gardens and bioswales, green roofs, retention ponds for infiltration, preservation of recharge zones, conservation easements, aquifer protection ordinances, like San Antonio's Proposition 1, land purchases, limiting impervious cover in key areas, public and political action support for Edwards Aquifer Authority regulation, pushback against sprawl on sensitive geologies, watershed-level planning, rather than parcel-by-parcel development. Bottom line, without sustainable planning and protection of recharge zones, the aquifer faces long-term degradation, threatening water security for millions in Central Texas. Would you like a map of recharge zones versus development zones, or a graphic novel version showing this visually for educational purposes?